Good evening, everyone. I am Dr. Shikhar Tyagi, Department of Statistics and Data Science, Christ University, Bangalore. First of all, I am thankful to the University of West Indies to provide me such a great opportunity. Today, I am going to talk about the introduction of queen theory. So this will be the list of content that I am going to cover today. So first of all, the introduction of the queen theory. Queen theory, also known as the science of waiting lines, i- that is a branch of applied mathematics and operation research that studies the behavior of queues and the waiting lines. It provides the mathematical models to analyze and optimize the performance of the systems involving the waiting lines, such as the service facilities, telecommunication networks, transportation systems, customer service centers, etc. Queuing theory is essential in a various fields for improving the efficiency and reducing the wait times and enhancing the customer satisfaction, especially in the if you just see in the hospitals and telecom companies where we need a lot of the methods to reduce the waiting time of the customers, so we can quickly provide them the uh, services. So, who invented the queuing theory? So, Erlang, Erlang was a Danish mathematician, engineer, and statistician who created the invention of queuing theory. He had done a groundbreaking work in the early 20th century in the field of the telecommunications. He developed the Erlang units, dimensionless units of the telecommunication traffic intensity, which became a fundamental in the queuing theory and the network traffic analysis during the Second World War. So, origin of the queuing theory arise I discussed earlier by the Erlang, who researched at the telephone exchange in the early 90s. Erlang's aim was to manage the growing telecommunications traffic efficiently and the optimize the performance of telephone networks. His work led to the fund, foundation of the mathematical analysis of waiting lines and the development queuing models to address the real life problems. So, what is the fundamental of the queuing theory that we have discussed? uh, we need to discuss. Queuing theory studies the behavior of the queues and the waiting lines in the system with limited resources. Key components of a queuing system includes the arrival, that is known as the rate at which customers arrive, service facilities, the capacity of the servers customers, and the waiting line, that is known as the queue, and the service mechanism, that is known as the process of the service customers. So important terminologies are there in the queuing theory that includes the arrival rates that we usually denote by the lambda, service rate that we usually denote by the mu, queue length that is denoted by the L, and the queue discipline that is known as the rule of serving customers, and the utilization that we denoted by the rho. All right, so that is the at the in the picture also, as we can see, we have the customers that are arriving. So that is called as the arrival time distribution, or calling the population. It may be finite or infinite. So we have the queue capacity of the queue that can be finite or infinite, and on the basis of that we have the queue discipline here. After that, there another segment is there that is called as the service. Number of servers, maybe we have one or more than one servers. On the basis of that we have the different models of queuing theory in the queuing theory. uh, so after that, next thing is that the applications of the queuing theory. Queuing theory can be applied in several domains, such as telecommunications networks, where we just organize the call routings and the network capacity planning. It will be very important at that time. And transportation systems, so to manage the traffic flow and scheduling the capacity and to optimize the capacity of the roads in the city. So at that time it could be very efficient. So after that, that is the third one is the health care facilities. So appointment scheduling resources allocation and patients flow management. So at that time, QN models are much essential. So after that, we had retail stores to check out the line management, staffing decisions, and the inventory control. At that time, we need the Queen models. In the customer service centers, especially in the call centers and service level agreements and the performance valuation, we need the Queen theory. So we have the different type of Queen models here. In that one, first one is known as the MM1 model. That is the one of the most simplest and most widely used queen model, that representing the single server queue with the position arrival and the exponentially distributed service times. That means the service times that provided to the each customers in a queue, that will be distributed by the exponential distributions, and the arrival of the people in the queue is based on the Gaussian distribution. So after that, we have the another models also there. We have several models in the queuing theory that includes the MMC multiple server queue model and MG1 general service time distribution, and more complex models are specific for the specific applications we are having. So now the case studies are that case study illustrate the practical applications of the queuing theory in a specific scenario or industry. And in that one, we can analyze the problem, identify based on the identifying the relevant queuing models, collected data, and propose the solution based on the queuing theory principles. After that, we can discuss the impact of the implementing queuing theory solutions on the system performance and the customer satisfactions. So again, we have several changes and challenges and the limitations in our queen models. First one is the simplifying the assumptions. So many queen models rely on the simplify assumptions that may not always hold true in the real world problem. All right. So that is one of the challenge that we have to face every time. Second is the complex system modeling. The complex systems accurately can be challenging due to the dynamic and the unpredictable factors. That may be one cause. And third one is the sensitivity to changes. So queen models are sensitive to changes in the system parameters, and a small deviation can lead to significant difference in prediction, that we should understand. So what are the future directions that we have and where we can use queen models? So integration with the advanced technologies. So our queen models integrate with the advanced technologies such as the artificial intelligence and machine learning for dynamic queue management. Second would be application in dynamic and unpredictable environments. So our queen model are designed for dynamic and unpredictable environments such as the cloud computing and the IoT network. So third one will be addressing the scalability and the efficiency challenges. Our innovative queuing strategies and the algorithms address scalability and the efficiency challenges in the modern systems. So on the basis of queen models, we have few references. So I showed three books in the references that we can refer for the further informations. Thank you so much.